You're here because you want to master measurement and experimental techniques with a University of Cambridge graduate. Hi, I'm Brendan, and I've been helping students like you achieve their mastery over chemistry over the past 8 years, and I hope that you can learn something from me today. Before we begin, be sure to go into the link below so that you can download a free copy of my notes and use it to follow through our lesson today. The first ever topic you ever learn as you step into chemistry in secondary 3 is measurement and experimental techniques. So part of which is learning about some of the physical quantities and their related SI units and their basic conversion. So physical quantities are like mass, time, temperature and volume, and you have to know the typical SI units that are used, which are basically the standard units which are used for these measurements itself. So for kilogram, we'll use it for mass generally, okay, and we must know how to convert to the relevant SI units. For example, okay, 1 kilogram equals to 1000 grams and 1 ton equals to 1000 kilograms. For time, we usually report it in seconds, so 1 hour is 60 minutes and 1 minute is 60 seconds. And for temperature, okay, we usually report it in Kelvin, not degrees Celsius. And how do we convert this? Well, Kelvin, okay, is degrees Celsius, any degree Celsius that where you add 273. Your volume, alright, usually is reported in cubic meters, right? And how this is related to dm cube and cm cube is as follows. 1 meter cube equals to 1000 dm cube, and a dm cube is actually equals to 1000 cm cube. And you come to realize that these conversions actually will be helpful later in the future as well as you tackle more calculations in chemistry. Next, some of the physical quantities and the apparatus that are used to go and measure them are, right, for mass, we usually use the electronic balance as expected, and do pay attention to the degree of accuracy. This actually comes in handy for your practical experimental errors. So the degree of accuracy for electronic balance is like plus 0.01 grams. Okay, for beam balance, it's about plus minus 0.05 grams. For time, right, usually we use a stopwatch. Okay, depending on the kind of stopwatch, right, you get a different degree of accuracy. So for analog stopwatch, it's plus minus 0.1 seconds, and digital stopwatch is plus minus 0.01 seconds. Again, it's kind of related to the decimal place in which the stopwatch can measure up to. Next, for temperature, right, if you use like a mercury or alcohol in glass thermometer, right, the degree of accuracy is about plus minus 0.5 degrees Celsius. If you use a data logger, it's actually pretty accurate, so it doesn't really have a degree of accuracy there. For volumes, alright, this is actually pretty important, right, because this is commonly asked. Okay, there are 3 different apparatus to measure volume. The more common one that you've probably well acquainted with is the measuring cylinder, and this, okay, is to the nearest 0.5 cm cube. So actually it's not that accurate, but it's pretty commonly used for very large volumes, and also generally if you don't need it to be too accurate. If you need something more accurate, you can use a burette. Alright, this burette can actually measure to the nearest 0.05 cm cube. And for a pipette, alright, it actually gives fixed volumes. So if you need specific volumes, for example, very common volumes to measure for pipette are 10.0 cm cube or 25.0 cm cube. Right, you can use a pipette for this case as well. It's very, very accurate. For gases, okay, typically they use a graduated gas syringe. Okay, and this can actually measure up to the nearest 1 cm cube. Next up, you need to know some of your common drying agents. Typically, your drying agents that you need to memorize include concentrated sulfuric acid, quicklime, which is your calcium oxide. I'll just write this over here. Okay, and your fused calcium chloride. Okay, but you need to know that there are some limitations when it comes to drying your gases, okay, with these drying agents. For example, concentrated sulfuric acid cannot really dry alkaline gases. The reason is because, okay, it can react with alkaline gases, because acid can react with alkali, as you will also learn a bit later down the line. Okay, so, and then your quicklime, your calcium oxide, doesn't really react with acidic gases. So the problem with this is that you do not want to react with the gas. Understand? Your fused calcium chloride doesn't really have a problem, so it generally is also more commonly used as well as a drying agent. And lastly, alright, you need to know about your methods of gas collection. So it really depends on a few different criteria. For example, if the gas is insoluble in water, right, you can generally use displacement in water. Obviously, because if the gas is soluble in water, it's not really a good idea to go and collect it by bubbling through water, for example over here, okay, and collecting it in the overhang or the overhead itself, because the gas could just dissolve in the water and your collection of the gas would be an inaccurate collection if you were trying to measure the volume of gas. Alright, and if the gas is soluble in water, okay, and has a relative MR of less than 28, MR means molecular mass, okay, then you can use upward delivery. Alright, in short, okay, if the gas is lighter and less dense, alright, then if it's less dense than air, you generally would use upward delivery because it would just float upwards, right? So you would collect it something like this, right, where you would have upward delivery. And if the gas is soluble in water and the relative molecular mass of the gas is more than 28, in other words, it's denser than air, then generally you will use downward delivery because it will just sink to the bottom over here. So this is an example over here so this is a typical example of how your downward delivery would work, and it will actually do upward displacement of air and you collect the gas as it sinks to the bottom.
If you enjoyed today's video, do remember to click the subscribe button so that you can enjoy more free content from us and improve your chemistry with us together. If you want to join my community of students to learn more secret formulas to acing chemistry, do check us out in the link below and sign up for a free trial class today.